Suppose I know that I have a function and I know it passes through the points 1, 2, and 5, 10. What happens between these 2 points? I haven't told you that. We don't know that. And this is very much a real world situation because often when you're dealing with data, you don't have the equation. You just know some things about it. You know that at year 1, you made $2 million. You know that at year 5, you made $10 million. You don't know anything about what happened. So what's one way that we could have gotten from 1, 2 to 5, 10? Yeah, we could totally do a linear thing, And if I know 2 points, I can come up with a linear equation that passes through those 2 points, right? And that's sort of the first thing we would think to look at is from my 2 points, I could come up with a linear thing. I guess by thing here, I mean equation. Is that the only way that I could get from 1, 2 to 5, 10? No, certainly not. So whatever my f of x is, I have an input and an output. And I can think about, I put in something and I get something out. If I worked 1 hour and I made $2 million an hour, then if I work 5 hours, I make $10 million, right? So for a linear function, the rate of change is completely predictable. It's very unlikely that you see that in the real world unless you're dealing with something like that where it's a constant rate. So what could be happening with the rate of change if it's not constant and predictable? If the rate of change is not constant, then the rate of change is either increasing or decreasing. It has to be changing somehow. So the rate of change is changing. What would it look like if the rate of change were increasing, if the slope were getting steeper in a positive direction? Like a parabola or an exponential, either one. So in what I've drawn in green here is an example of what it would look like if this curve were concave up. You can think of this as you're stepping on the gas. So in the pink curve, you're moving at a steady speed. In green, you're stepping on the gas. What would concave down look like? It'd look like this, right? This would be concave down. You're not getting faster here. You're actually getting slower. You're still moving forward. So these are 3 different shapes to think about: linear, concave down, and concave up. Now let's think about this in terms of linearity of input. If I make $2 million an hour, and I always make $2 million per hour, does it matter whether I work in 1-minute chunks or in 1-hour chunks or in 10-hour chunks? No, I always make $10 million an hour. That would be linear. And it doesn't matter whether I do 1 hour or whether I do 6 10-minute blocks or whether I do 10 6-minute blocks or whether I do 61-minute blocks. If I get paid an hourly rate, then I can chop these things up however I want. It doesn't matter. Scenarios that you see in the real world. No.